Today, I would like to introduce our speaker, Dr. Megan Friggens, who is a research ecologist for the Rocky Mountain Research Station in Albuquerque, New Mexico. Her work involves using a variety of methods to assess future threats and impacts to wildlife species and habitats arising from climate change and related disturbances. She's going to speak about some of the approaches taken to integrate climate change impacts into state and federal management plans. Dr. Friggens, welcome and thank you for joining us today.
Thank you. So I'm going to share my screen here. And does that look like a presentation to you?
There it is, yes.
All right, okay. Well, thank you everyone for being here today. Yeah, I'm going to be talking about integrating climate change into state and federal resource management. And in particular, I'll talk about the role of vulnerability assessments, specifically talking about some of the things that we've done at the Rocky Mountain Research Station with a particular tool that we've been using. So, here we go. So just to begin, obviously climate change poses a lot of challenges to resource managers. A lot of the impacts of climate changes are occurring rapidly. We've already seen some of these changes and we expect them to continue. These impacts cross jurisdictional boundaries. So there's a new, or maybe it's not new, but there's extra considerations when you're planning into the future where you may have habitats, ecosystems, species moving across landscapes. Variation in species responses and interactive effects between species and their habitats and disturbances can create a lot of complexities that are hard to plan for as well. So there is a continuing need for science-based information to help with adaptation planning, that help us respond to these changes. So enter the vulnerability assessment. I'm sure many of the people that are listening today are familiar with vulnerability assessments. They are one of our primary tools for evaluating climate change impacts. They're specifically designed to identify and communicate climate change impacts and uncertainties in such a way that we can start to identify management strategies for dealing with vulnerabilities. And so I did not put in today's webinar a view of one of the many flowcharts that many agencies and organizations have for adaptation planning or the process, but I think this is recognized as a first step in many adaptation plans, and within the Forest Service certainly is your assessment step. So vulnerability assessments work through a variety of ways. There's a variety of forms, but for climate change, we often look at this diagram that you see up on the screen, where vulnerability is broken down into exposure, sensitivity, and adaptive capacity elements. And so exposure is essentially your magnitude change in climate, and sensitivity is the response of your particular target, whether it's a species or ecosystem, to that exposure. And so collectively, that represents your potential impact. And a lot of studies of climate change are measuring potential impact. So if you have this degree change in temperature, what is the outcome on my particular target? But to really understand vulnerability, you have to also consider adaptive capacity, which essentially, it can be defined as a variety of things, but essentially it's your target's resilience to this impact. How well is it able to bounce back? And I work across a variety of scales at species and ecosystems and habitats. And so I'm pretty inclusive about how I think about adaptive capacity. It can mean a number of things. So when you consider all of these elements, you have some measure of vulnerability, which here is defined as the degree of susceptibility of your target to adverse effects from climate change. And so one of the ways that vulnerability assessments work is by partitioning the information that you may have about climate change into these various categories. And then you can take this information that is organized like this and start to identify adaptation strategies for maybe reducing exposure or reducing sensitivity or increasing adaptive capacity. And so it ties in and organizes the information so that you can start to plan. And I think I mentioned this, but there's a variety of ways that vulnerability assessments can be done. They can use a variety of qualitative and quantitative methods. And it really depends on your target and what your aim is. So for a lot of today's talk, I'm going to be talking about a species level assessment that was developed in the Rocky Mountain Research Station with partners from the Forest Service, National Forest, and Nature Conservancy, the DoD, Fish and Wildlife. There was a lot of partners that got together and wanted to develop tools to help managers be able to incorporate climate change into their planning. And so this was developed and published in 2011. And right around this time in the Forest Service in particular, we had the introduction of the climate change scorecard and the 2012 forest forest planning documents that started talking about climate change, as well. These other agencies too were starting to formalize considering climate change into their planning processes. And so there was a real need, and there continues to be, for these types of tools. So the System for Assessing Vulnerability of Species, and I pronounce it SAVES, to climate change is a trait-based tool. It's, again, for animal species, if I haven't said that. And it is based on 22 species traits that are predictive of the species response to climate change. So predictive in the sense that if it's exposed, this trait may help it deal with climate change, or it may be sensitive to a particular climate change. So these traits relate to these categories. We have habitat related traits. So, how many habitats does a species occupy? Can it move between habitats? Does it rely on specific elements within a habitat, like nesting sites or something like that? We have physiology, which deals a lot with metabolic processes and just maybe innate sensitivity of a species to heat, so heat tolerances, if it can torpor, if it hibernates, things like that. Phenology deals with the timing of things, so this has a lot to do with reproductive cycles and migration patterns. If a species reproduction or migration is timed to a climate variable, it is going to be at an increased risk of a negative impact, given that those are the things that are changing. And then biotic interactions deals with predation, competitors, disease, those kinds of things. And so this diagram that you see here is just showing you that you go through and fill out a form based on those various traits, and then there's some calculations that occur, and what you get at the end is a score. And so the score can be used to prioritize or identify the most vulnerable from the least vulnerable. And then there's a lot of information to be had, and I'll talk about this more later, regarding which of these traits are actually driving the vulnerability. And that information can actually point to management strategies. So the SAVES tool, we have a GTR that's an instruction manual here that you see on the left-hand side of your screen. This isn't overly long, but it does give you a review of why we have these 22 traits, other traits that were considered but didn't fit the criteria that was needed for a tool that we wanted to be widely applicable to various species. We also have this web-based form, and I have a link to this tool at the end of this presentation as well. And I want to highlight, temporarily the link won't work. We're moving the location of the tool, and so ironically this week you would not be able to get to it, but that will be short-lived. So click on it next week and we'll be good to go. But in any case, there's also within this guidance document, this GTR, fairly intensive appendix that talks about the types of information you need to gather in order to be able to answer the questions. So for instance, you need to identify how climate is changing in your particular study area and what you expect to happen to habitats in order that you can answer questions about your species and what it's being exposed to. So there's that element. So We're talking about this today because the SAVES tool has been around long enough that we have been able to use it in a variety of settings and in a variety of places. So and we have used it with state collaborations and with Forest Service, National Forest entities too. So, and the Department of Defense for that matter. So what this is showing you is just some of the case studies and analyses that we have participated in or used the SAVE system in. So we have some in the Northeast. We have this large block here in the West, which is representing Region 4 of the Forest Service. We have the state of New Mexico, then some more local areas where we worked producing case studies for the Nature Conservancy and some adaptation workshops that they were conducting, and then some analyses that are using more derived versions of the SAVES tool. So integrating the SAVES tool with spatial analysis, in particular habitat suitability analysis, to fill in some gaps that are often in habitat suitability analyses, where they cannot often consider all the various ways in which species can, the adaptive capacity element, maybe I should just simplify it like that. So I'm going to talk about a couple of these case studies in the next few slides. And in particular, we're going to start with this collaboration with the New Mexico Game and Fish. And so a few years after we had finished the tool and we had done a few case studies, the New Mexico Game and Fish was in the process of revising their state wildlife action plan. And so I'm not an expert in these, but these are essentially blueprints for planning and implementation for wildlife and habitat conservation initiatives within the state. And each state is required to create these plans, and then I believe that they need to be updated every 10 years or so. And if anybody's online that knows better than that, you're welcome to chime in, but I'm pretty sure that that's right. And so in the 2016 swap, as I'm going to call it, I was contacted to help create a climate change chapter. I think that it hadn't been incorporated into the swaps previous to this. And I had been working a lot with vulnerability assessments at that point. And so they had a really well-organized team of not only state, but federal, and I think some other partners that had been working on the New Mexico swap. And so I was invited to participate after they had a pretty good streamlined process for what they wanted. We produced a report that addressed a number of different items that they wanted summarized, and it is pretty hefty, and it can be found as a separate document from the actual state wildlife action plan. The climate change chapter in here is a really nice, concise review of various things that I'll talk about in just a minute. So for this particular assessment exercise, there was a step approach. First, we wanted to review the climate changes for New Mexico, recent and projected changes for this area. Secondly, we wanted to review the ecological impacts of climate change for vegetation systems within New Mexico, and they use this natural vegetation classification standard, macro groups. And so you'll see if you look at this document, in particular the longer one, there's little synopses of climate change impacts for a number of different vegetation groups. And then finally, we conducted species vulnerability assessments, in particular focusing on the sensitivity and adaptive capacity factors or traits that are used in the SAVE system for 21 species of greatest conservation need. It does take a little bit of work to conduct a vulnerability assessment because of the data that you have to gather for these. So this was the number of species we felt we could do in the time that we were given for this. So we had a number of contributors, Karen Bagney, who is one of the original authors of the SAVE systems. Jack Tripke is with Region 3, which contain of the Forest Service, which contains New Mexico and Arizona. And he actually provided analysis of vulnerability assessment and surface, I guess I should say, a spatial data set for ecosystem. Oh, this is what the Forest Service uses. Oh, I'm blanking on it right now. Their ecological. Oh, well, we'll pass that. But anyways, that was one of the things we crosswalked that with the state vegetation and classification system that they were using, and use the projections of future impacts and vulnerability in our analysis. So that was a really good crosswalk between the state, the federal agencies there. So as I said, I think in the beginning, the New Mexico SWAP team was really well organized. They knew what they wanted. And so by the time they came to me to ask for this climate change chapter, they had a really nice outline of the information, and we just simply provided that. So this is showing you some of the main topics that were covered within the report. How have climates and habitats changed in New Mexico, kind of more recent periods? How are they expected to change? Trends for temperature and precipitation. There's a section on extreme weather. And then within the SWAP, this document, there is a really nice format where they focus on stressors, and there's a particular classification that they're using for their stressors. And so within the climate change chapter, we wanted to talk about how climate could interact with various of those stressors. And I've consolidated this a little bit. There's a lot more categories, but for the sake of the slide, this has been consolidated a little bit. So I think that this section and in the document, the SWAP action, this plan itself, there's some really nice discussion about these different stressors and then their interactions. And then items 7 and 8 here, summaries of specific vegetation responses. Again, that's kind of the, I guess, assessment of the terrestrial systems, the habitats, we'll say, and then the vulnerability of the species of greatest conservation concern, and that is backwards, excuse me, to climate change. And so these items 7 and 8, I think you could probably consider the vulnerability assessment component. Now, this component in every vulnerability assessment is going to be best, most effective when it's tailored to what the users want. And really what the New Mexico group wanted for this assessment was not so much that quantified ranking number that the SAVES provide, but rather that information on how things were going to be affected, what were the sensitivities and what were the resiliencies, because that can point to potential conservation actions. And so I think too, we didn't want to identify for a vulnerability assessment, usually you have to identify an end time point. So you say, okay, in 2050, this is what we expect the climate to be, and this is what looks to be most vulnerable given this scenario. We didn't want to necessarily tie into a single scenario in this document. And so what we present are case studies for each of the species that do talk about the actual SAVES results, but we actually used a modified version of SAVES that really focused on those sensitivities and the resiliencies and presented the information as you see here. So this is an excerpt, a table where we have the species, and it's not all 21 species, of course. I wanted to make it hopefully somewhat readable. But we talk about the species, and we talk about the critical vulnerabilities, resiliencies, and then importantly, information needs. And I haven't really talked about this, but quantifying or considering uncertainties is really one of the key requirements of any vulnerability assessment. And so here we talked about uncertainties with respect to information needs. So what were those aspects or those either things about future conditions or things about the animal itself that were potentially driving or that we need more information about to be able to better understand the future. So if we look at this first species, the Jemez Mountain salamander, critical vulnerabilities related to some of its physiological kind of biological things. It doesn't really disperse. It needs some moisture. It does have some resiliencies, and then it can torpor. It does have a pretty protected habitat, which is a benefit as compared to species that maybe nest on the surface. But there's a lot that isn't known about fire effects, and chytrid infections were strong in many of the species. I will point out that this is the only place where you'll see saves looking at insects, and so there was some desire, not just insects, but there was some desire to look at species of greatest conservation need that weren't terrestrial vertebrates. And Karen Bagney, we tasked her with doing these, and she did a really great job. And she's also worked the SAVE system or a modification of it with plants, but these aren't official or particularly they're not vetted enough to be distributed. But for here, we did use the saves and some of those traits to find out some things. So it's the only place you'll see that. But in any case, this is the product that we produced for the state so that it could provide information. And I think some of what you can do when you start to outline critical vulnerabilities or sensitivities or all these traits is to look for common issues amongst your suite of species that you're assessing and then your habitats, and find those strategies that maybe will address multiple species or multiple strategies. And I think if you've been involved in this, you can imagine a variety of ways that you can use this information. So the second thing I'll talk about is going to be a larger analysis of Region 4 of the Forest Service and our role in that climate change assessment. And so this map that you see here is an excerpt or a screenshot of the web page of the Intermountain Adaptation Partners. And so this is a collaboration that was formed to conduct a comprehensive climate change assessment for Region 4 of the Forest Service, which covers national forest here highlighted in green, in national forest in Utah, Wyoming, Idaho, and Nevada, yes. So I'm missing something up here. So I led the terrestrial species chapter of this assessment, and this assessment is published in 2 GTRs that are pretty big. It's very comprehensive. So I led the terrestrial species chapter, but there's an entire chapter just about climate changes in Region 4 and in the various areas of Region 4, I believe. There's a chapter on climate changes on infrastructure, on recreation, on vegetation communities, aquatic communities, all of these different things. I'm probably forgetting some, but it's very comprehensive. It is a product produced for the Forest Service and meant to, I think, help them plan and a little bit with their forest revisions and things like that. For this activity, for this particular collaboration though, the Intermountain Adaptation Partners were using the results of the vulnerability assessments to develop adaptation actions in science management partnership workshops. And so I think that this is a really good example for a couple reasons of vulnerability assessments and how we can incorporate climate change into state and federal planning activities, because it can be not only this product, this GTR that you can use as a reference, but it can be a starting off point for workshops. And certainly we've used these in collaborations or collaborative type workshops where you have multiple agencies. You use it to begin the discussion, to find common issues and to identify management strategies for dealing with things. So that discussion can be just as important as having some kind of reference. So the approach for the R4 or AIP assessment, as I'll call it, for the terrestrial species chapter, each chapter was led by an independent person. They all took their own approaches. Unlike the swap activity where there was a team that had a very focused idea and gave us a list of this is what we want you to cover, and we talked a little bit about species to assess there. This one was left a little bit more open, and so we talked with some of the folks on the National Forest there, as well as, of course, the regional contacts who were super helpful about what kind of format, what kind of assessment do we want of terrestrial species that will be most helpful for the region's needs. And so from that, we wanted to cover our bases in that trying to identify climate change impacts for the larger ecological systems that exist there, the habitats, I should say, and then also to use the SAVE system to drill down a little bit and look at specific species and identify specific issues. And so we, again, there was some time limitations on what we could do, so we had to cull a lot of our wish list of what we ended up assessing. I think we had 15 species, but we did have a lot of habitats. So we did have a good team here. Karen again came in working a lot with the species assessment, Sam Cushman from RMRS, Mary Williams, and Tasha Wixom from the region. So these are the wildlife habitats that we created summaries for. So what we essentially did is looked at the literature of recent changes, what future projections were saying, and we didn't try to focus on the future projections so much because there can be some uncertainty with them, but we use that to inform us maybe how much disturbance the system could expect. We tried to complement the vegetation groupings in the vegetation chapter, but the way a wildlife person might look at vegetation communities is going to be a little bit different than the way maybe a botanist would. So it's not a perfect complement, but we tried to make sense there. And you can see that there's a number of communities. And so for each of these, we also looked at the species, the animal cohorts that are associated with them, and how they might be impacted by the potential changes happening to these ecosystems. So this takes the bulk of the chapter, the terrestrial species chapter, because there's a lot going on here. We did in the chapter, and then there's a whole separate chapter in the GTR series, start to look at trends and identify adaptation strategies that, or I guess priority needs, maybe we should say. So if we looked at the habitat changes, this is kind of the general things that we saw. We saw loss, shift, expansion of habitats. So everything was expected to change. Even where there was minimal change, maybe in where a habitat was located, there was substantial changes expected in the structure and composition of the species. So changes in dominant overstory species or in the age classes within forest and things like that, that will probably have a really big effect on the wildlife species. So loss of critical habitat elements, so this is everything from ponds to large trees. That was common throughout the assessment. Changes in the timing of resources, so snowpack is a big deal here in this area. They get a lot of snow and it melts and has hydrological impacts and things like that. Changes in disturbances, fire is a big deal, and then flooding too to some degree. And then changes in snow cover, because this is an area that gets a lot of snow cover. There's a lot of species that have adapted to that. And so the expectations for maybe not less snow, but less snow on the ground, the duration that the snow is on the ground might change. And the time that it takes for the snow to melt might change. So for our species vulnerability, kind of a more traditional qualitative assessment of vulnerability, we assessed these 15 species. They were all of management concern. They have, of course, hundreds more than this. But we wanted to pick species that were present within the forest. That may sound like an obvious thing, but each of the forests may have a unique set of species. So we tried to find species that maybe were relevant to more than one of the forests in the region. We also tried to select species that would be representative of the different habitats that the forest contained. So lowland species, highland species, things like that. And then finally, we had to have some level of data available. And for many of the species, there might be studies in different areas, but nothing specific to this area. And the assessment is really improved if you have information on your species in its own area, because sometimes things can vary a lot across the species range with respect to how well it, even how far it travels, its reproductive habits and things. And then if it's exposed to different competitors too, that often changes. So here in this assessment, again, we did want to look at the ranking of species. So the higher the score, the more vulnerable it was. So the collective impact or the collective outcome of assessing all those traits was that the wolverine was our most vulnerable species and the American three-toed woodpecker was our least vulnerable. Uncertainty scores, which are included, and I haven't emphasized this, but I did mention it earlier, are included with this tool, very important to consider. And they were pretty high for all these species. And in part, it was because we didn't have a lot of specific region 4 studies for these species. So much of the information when we had it was coming from surrounding areas. And that increases your uncertainty when you're asking, well, how will it do with changes in, heat waves or drought or things? If you haven't seen that in that area, it can be difficult to answer. There were also these knowledge gaps with respect to disease. The chytrid fungus was important for some, and then some avian things too. Competition, and then food resources. A difficult thing in many of our case studies has been to really assess what's going to happen with the insects. Are we going to see the same level of productivity, and it'll just be a transition on the types of insects? And what does that mean if you have moth specialist or beetle specialist? It's really difficult to say what's going to happen with the insects, and that's always information need for many of these. Okay. So we did talk about, this is somewhat similar to the SWOP, the general attributes, kind of those characteristics that seem to be indicative of increased vulnerability or decreased vulnerability. And so I don't know if I mentioned this, but I did. A big point of doing these vulnerability assessments was that each lead would go to a series of workshops after we had completed this and present this information. And then this was a starting off point for discussions to identify specific actions that can be taken to mitigate or reduce vulnerabilities in a variety of ways for the species. So we always showed slides for this, and the region was actually broken up into 4 or 5 regions. So there was a series of workshops that were kind of focused on these different areas, which helped because they all have their unique situations. So here we see increased vulnerability, and this is, I think this was from my final presentation, and so it's more about the big picture for the entire region, not a particular one. But when you had species, those that were more vulnerable tended to be vulnerable because they were going to experience a loss in habitat, in particular high elevation habitats, open water and wetlands. Species that required snowpack generally came out more vulnerable. Those that had pretty narrow reproductive windows or that migrated in response to weather cues or following green up, like some of the deer do, they had increased vulnerability from that perspective. If they didn't like fire, fire is expected to still remain an issue in this area. So the species that don't like it aren't going to be favored. Potential increases in disease just due to changes in animal movements, novel introductions, and crowding potentially at more limited habitats. And increased issues with barriers. That's both anthropogenic barriers like roads and energy development, but also kind of the natural thing that'll happen when you start to see habitats move up in elevation and you get these islands that species can't cross in between. There were species that didn't seem like they're going to be too negatively impacted. If they had high mobility, that always helps species. If they can move to a new area, that's always helpful. If they could breed year round, they're going to be less affected by changes in the timing of things that can be more opportunistic. If they were going to experience habitat increases, and so I think the shrub habitats and some different types are expected to increase. Increased winter foraging with less snowpack, that opens up potentially more of the high elevation habitat that's often not available to some of the ungulate species. And so that was an interesting finding. And then with some expected loss in permanent water bodies and maybe water bodies shifting to more ephemeral sources, reduced fish predation. So all of these things, I went through this, took a little time, but all of these things can be related to specific actions. And a lot of the workshop discussion were geared towards identifying and compiling these actions. And I have a website that I will refer to. Let me see how far. Okay, I have a few more slides, but I have a website at the end where the adaptation partners have compiled from this region 4 analysis, but from other regions as well, all these adaptation strategies and have them organized. And so it's a really great library of potential actions. So I wanted to point out some uncertainties common to all of these assessments, and not only the New Mexico and Region 4, but all these other case studies. And one is that similar climate, projections of a similar climate in the future does not necessarily mean you're going to get a similar habitat, particularly when you're talking in the next 50 years. You're not going to see a perfect transition from one ecosystem type to another. Things take longer than that to establish and to move, for that matter. So we have to be cautious about those interpretations, but it can give us a measure of that magnitude change. And so we can relate that to exposure. If you don't see any similar climate in your study area now, in the future, that's giving you some idea that there's something going to change. Dynamic habitat responses. There's a lot of moving parts in any ecosystem or habitat, and species themselves and their communities, and that dynamic nature of how some things can move faster or slower can really complicate future things. Some terrestrial species may be more or less resilient to change than is currently known. There's a lot of research and monitoring to be done to be able to assess how well we are identifying those most vulnerable species. And then of course there's these agents of rapid change that are influenced by climate, and then once present in the landscape can instigate changes in advance of any climate changes. So invasive species, fire, other mutualisms and interactions, diseases. So my final thoughts, just to review, kind of hopefully bring this back to the point of the title. So vulnerability assessments, they can be used to identify management priorities. You can use them to rank, like the SAVES tool, to rank species and to say, okay, this one looks like it's critically vulnerable. These look like this is going to be less of an issue for them. I think most importantly, though, they can be used to identify specific strategies to address drivers of vulnerability. Vulnerability assessments can be used in a variety of ways. So you can use them in management strategy documents, like the climate change chapter in the SWAP, which lists climate change impacts and covers that topic and kind of uses the assessments as a tool for case studies and demonstrating various things about how climate change may influence wildlife. You can also use it in these adaptation forums and workshops too, as a starting off point for discussions and brainstorming. And I think that that's a very valuable way to bring the climate change information into any agency's planning efforts. So observations in general about the process of integrating climate change and vulnerability assessment outcomes into resource management. It's very important. I think it's most effective, I should say, I'll keep to the words here, when a strong team of both scientists and managers are formed at the onset of the process, so that they can clearly identify what they want from the process and what they need. And I would add too that you need folks that are in the field at that local scale, as well as at a regional or larger scale, so that you can get both perspectives on what is needed at the higher levels, as well as what's useful at the lower levels. And then vulnerability assessments always improve with iteration. So as new information becomes available, they should be updated. Even in the workshops, getting feedback about, well, actually this species in this area, we haven't seen that, and so you can modify it based on expert opinion. That's been very helpful, because the literature-based vulnerability assessment, or even a modeling-based one, is going to be limited by the understanding from a more general perspective, and so that local knowledge can be very helpful. So my last slide, I have a link to the SAVES tool. Again, it won't work today, maybe it'll work tomorrow, but next week I think we should be on board, so I apologize for that, but just ironic timing. The GTR, if you're interested in looking at that, I think it provides a lot of information on the New Mexico swap. This is, well, and I am actually linking to the report. They've updated it for 2019. There's a new version, but it has a lot of the same material. But I think that that document is a really nice comprehensive example of how to look at wildlife and their habitats, and in particular, those stressors and how they consider them. And then of course there's this pretty large PDF that talks more detail than probably anybody wants about different terrestrial systems and habitats. The R4 vulnerability assessment, this is a two-part GTR, and then the Forest Service Climate Change Adaptation Library, which I talked about really briefly. You can just go to the adaptationpartners.org website and you can find all those links. And then I have some other GTRs if you're interested in looking at the other case studies. So that is it for me. Now, I'll just leave this up here for now, right? Okay.
Thank you, Dr. Friggens.